don't know if you got a chance to see it, the blog post called Bitter Lesson
Oh, yes.
by Rich Sutton that makes an argument. Hopefully I can summarize it. Perhaps you can. Yeah, but do you want,
okay.
so I mean, I could try and you can correct me, which is, he makes an argument that it seems if we look at the long arc of the history of the artificial intelligence field, he calls, 70 years, that the algorithms from which we've seen the biggest improvements in practice are the very simple, like dumb algorithms that are able to leverage computation. And you just wait for the computation to improve. Like all of the academics and so on have fun by finding little tricks and congratulate themselves on those tricks. And sometimes those tricks can be like that feel in the moment like big spikes and breakthroughs, but in reality, over the decades, it's still the same dumb algorithm that just waits for the compute to get faster and faster. Do you find that to be an interesting argument against the entirety of the field of machine learning as an academic discipline?
That we're really just a subfield of computer architecture.
Yeah.
We're just kind of waiting around for them to do
Who
their
really
next thing.
don't want to do hardware work. So like,
that's right. I really don't want to.
We're procrastinating.
Yes, that's right. Just waiting for them to do their job so that we can pretend to have done ours. So, yeah, I mean, the argument reminds me a lot of I think it was a Fred Jelinek quote, early computational linguist, who said, we're building these computational linguistic systems, and every time we fire a linguist, performance goes up by 10%, something like that. And so the idea of us building the knowledge in that case was much less. He was finding it to be much less successful than get rid of the people who know about language as a from a kind of scholastic academic kind of perspective and replace them with more compute. And so I think this is kind of a modern version of that story, which is, okay, we want to do better on machine vision. You could build in all these, motivated part-based models that, that just feel like obviously the right thing that you have to have, or we can throw a lot of data at it. And guess what? We're doing better with a lot of data. So I hadn't thought about it until this moment in this way. But what I believe, I've thought about what I believe. What I believe is that, compositionality and what's the right way to say it? The complexity grows rapidly as you consider more and more possibilities, like explosively. And so far, Moore's law has also been growing explosively, exponentially. And so it really does seem like, well, we don't have to think really hard about the algorithm design or the way that we build the systems, because the best benefit we could get is exponential, and the best benefit that we can get from waiting is exponential. So we can just wait. That's got to end, right? And there's hints now that Moore's law is starting to feel some friction. The world is pushing back a little bit. One thing that I don't know, do lots of people know this? I didn't know this. I was trying to write an essay, and yeah, Moore's law has been amazing, and it's enabled all sorts of things. But there's also a kind of counter Moore's law, which is that the development cost for each successive generation of chips also is doubling. Mm-hmm. So it's costing twice as much money. So the amount of development money per cycle or whatever is actually sort of constant. And at some point, we run out of money. Or we have to come up with an entirely different way of doing the development process. So like, I guess I was always a bit skeptical of look, it's an exponential curve, therefore it has no end. Soon the number of people going to NeurIPS will be greater than the population of the Earth. Yes. That means we're going to discover life on other planets. No, it doesn't. It means that we're in a sigmoid curve on the front half, which looks a lot like an exponential. The second half is going to look a lot like diminishing returns.
Yeah, but the interesting thing about Moore's law, if you actually look at the technologies involved, it's hundreds, if not thousands, of S-curves stacked on top of each other. It's not actually an exponential curve. It's constant breakthroughs. And then what becomes useful to think about, which is exactly what you're saying, the cost of development, like the size of teams, the amount of resources that are invested in continuing to find new S-curves, new breakthroughs. And yeah, it's an interesting idea. If we live in the moment, if we sit here today, it seems to be the reasonable thing to say that exponentials end. And yet in the software realm, they just keep
They
appearing to
keep
be
happening
happening.
anyway.
And it's so, I mean, it's so hard to disagree with Elon Musk on this, because it like I've, I used to be one of those folks. I'm still one of those folks. I studied autonomous vehicles. That's what I worked on. And it's like, you look at what Elon Musk is saying about autonomous vehicles. Well, obviously, in a couple of years, or in a year, or next month, we'll have fully autonomous vehicles. Like, there's no reason why we can't. Driving is pretty simple. Like, it's just a learning problem, and you just need to convert all the driving that we're doing into data, and just have a neural network that trains on that data. And like, we use only our eyes, so you can use cameras, and you can train on it. And it's like, yeah, that that should work. And then you put that hat on, like the philosophical hat, but then you put the pragmatic hat, and it's like, this is what the flaws of computer vision are. Like, this is what it means to train at scale. And then you put the human factors, the psychology hat on, which is like, it's actually driving is a lot, the cognitive science, or cognitive, whatever the heck you call it, it's really hard. It's much harder to drive than we realize. There's a much larger number of edge cases. So building up an intuition around this around exponential is really difficult. And on top of that, the pandemic is making us think about exponentials, making us realize that, like, we don't understand anything about it. We're not able to intuit exponentials. We're either
That's true.
ultra terrified, some part of the population, and some part is like uh the opposite of whatever, the carefree, and we're not managing it very well.
Blase.
Blase. Well, wow, is that French?
I assume so. It's got an accent.
So it's fascinating to think what the limits of this exponential growth of technology. It's not just Moore's law, it's technology, how that rubs up against the bitter lesson and GPT-3 and self-play mechanisms.